Hello students, in this video we are going to discuss CBSE class 9 Maths chapter 7 triangles, the second question in exercise 7.2. Let's look into the question, children. So in the question we are given a triangle ABC where AD is the perpendicular bisector. Okay, AD is the perpendicular bisector of this line BC. Show that triangle ABC is an isosceles triangle. Here we have to prove that triangle ABC is isosceles. So before getting into the question, I just do a quick recap of what is a perpendicular bisector. You all know perpendicular means it is going to have a 90 degree. But bisector, when you have the perpendicular bisector, the word bisector, you should know what it is going to bisect. Bisect means dividing into two. When we spoke about angle bisector, it divided the angle into two equal halves. Here this perpendicular bisector, it means it is a line that divides a given line segment into two equal halves. Which line segment? This line segment BD. So it is going to, this line is going to divide this line segment BD into two equal halves at a 90 degree angle. Okay, and this will pass through the midpoint of the line segment. That is just another meaning that it is dividing into two equal halves. So that means we are given that BD is equal to DC. BD is equal to DC, and we know that it is a perpendicular bisector. So we know angle ADB is equal to angle ADC, which is going to be equal to 90 degree. Okay, so first we need to prove that AB is equal to AC. For that, if we prove that these two triangles are congruent, then that is going to be done easily. So we will draw the two triangles here separately. Okay, so let it be ABD, and then we have ACD. Okay, where we know that BD is equal to DC. So these two are already equal. Okay, this angle is equal to 90 degree. Then you have AD. AD is going to be common. AD is common. Is it clear, children? So now what do we have? So AD is common. So this is also going to be equal. So we have the side angle side congruency. So therefore triangle ABD is congruent to triangle ACD by SAS congruency. SAS congruency. So when these two triangles are congruent, as per the corresponding parts of congruent triangles, we will have this AB is equal to AC. Okay, so therefore AB is equal to AC. This is by corresponding parts of congruent triangles, and thus we have proved that AB is equal to AC, and then we are able to say that if AB is equal to AC, we can say therefore triangle ABC is an isosceles triangle. Is it clear, children? So that's all. We are done with the second question also. The main thing which you have to be very careful is this perpendicular bisector. Which is the perpendicular bisector? AD. So we have a triangle ABC where AD is a perpendicular bisector of BC. So from A to BC you are drawing a line, and that line is at 90 degree, and it divides this line into two equal halves, or it passes through the midpoint of the line segment. That is what is given here. Here, children. So if you know all these small concepts, it will be easy for you to solve these kind of questions. Is it clear, children? Hope you've understood this. If you have any doubts, please listen to the video once again. We'll do the next question in the upcoming video, children. Thank you, children.